Hello, today's lecture will be on Arden's theorem. We will see what is the theorem, and we will prove that theorem, and we will see what are the application of this theorem, and we will try out with one or two examples. Okay. First, see what is the need of Arden's theorem. In order to find out regular expression of a finite automaton, we use Arden's theorem along with the properties of regular expression. If you are given a finite automata, how to find out the regular expression? Arden's theorem will help you here. What the theorem states, if P and Q are two regular expression and if P does not contain any null string, then we can write R equals to Q plus RP, and that has a unique solution called R equals to QP star. Okay, so how it is coming, we will see in the next slide how to prove it out, that if R equals to Q plus RP, and how it can have a unique solution R equals to QP star. Fine. So first remember that R is equals to Q plus RP. Fine. So here what we will do, we will keep on putting the value of R in place of R in the right hand side. Right. So R equals to Q plus RP. If we put R equals to Q plus RP again, so it will become Q plus, within bracket Q plus RP whole multiplied by P. Fine. So it is coming to Q plus QP plus RPP. If we keep on putting the value of R repeatedly, it will generate like this. You can see in the first in the expression there is Q, then QP, then if we again put it, you can then it will ultimately QP square, then QP cube, and in this fashion it will follow. So if we take Q as common, so what are the strings remaining? First there is no P, so it is epsilon, then single P, then P square, then P cube, and so on. So what you can write? Obviously P star. So we can prove it that R is equals to QP star. It is very easy to understand. Fine. So what are the assumptions of the Arden's theorem? The transition diagram must not have any null transition. So if our any automata is given where epsilon transition is there, our first job will be to eliminate those. We have already learned how to discard the epsilon transition in DFA. So we have to apply those, then we can apply Arden's theorem to generate what the regular expression it is denoting. It must have only one initial state. It is, in most of the cases, finite automata have only one initial state. Okay. Next, how to find out, means if our automata is given, how we will be able to find out the regular expression. I am just reading out the steps, but I think it will be much clearer when we move to the example. For now, let us concentrate on this. So create equations as the following form, means we will create some equations. Okay. How to create it? Here Q are the states and R11 means the transition. Okay. So with respect to Q1, we will just include those transition which are coming into it. We will not concentrate on those transition which is going out of it. Okay. So say Q1 is having one transition from in self loop. It is going out of it and coming into it. So it will be R11. It is going out of Q1 and coming to Q1 only. If there is one transition that it is Q2, one transition is coming from Q2 to Q1, so it will be R21. In this fashion you can do. And remember one thing, for our initial state we have to include empty string. Okay, this is the assumption. Next, for Q2 similarly you can do this, and we will come out with the ultimate generalized expression. Fine. So now let us see an example. Now the problem is given. It is having three states. Q1 is initial state, and there are two entries in Q1, one from Q1 itself, that is with the value A, and Q3 is giving A to Q1, and we have to remember that Q1 is the initial state. So accordingly we have to build up the equation or expressions. So Q1 will be equals to Q1 dot A, Q3 dot A, and one epsilon, because it is the initial state. Now for Q2, what are the incoming edges? One B is coming from Q1, another B is coming from itself only, another B is coming from Q3. So accordingly Q2's expression has been built, and you can build the expression for Q3 as well. Now if we concentrate on Q2 and place the value of Q3 in it, so what will be the expression like? It will be Q1B plus Q2B, and putting the value of Q3, it will be like Q2AB. So if you take Q2 common from the last two values, it will be Q2 into B plus AB. So if you follow what Arden's theorem says, if R equals to Q plus RP, then R equals to Q dot P star. So here Q is equal to Q1B and P is equal to B plus AB. So what will be our ultimately Q1B dot B plus AB whole star, right? Fine. Next we will find out that for Q1 as well. Okay, we have done it for Q2, now we have to find it for Q1. Similarly, we will substitute the values, and please apply Arden's theorem, and you will be able to find out this. So why we are finding out Q1? Because in our previous expression, the expression contained Q1, so we have to find out the regular expression only, and please put this Q1 value there, so you will come up with this result. One more problem. Again, just see the transition. Same initial state is Q1, so we have to build accordingly. We will come up with these equations. Here inputs are 0 and 1, so these are the equations coming out. Next, what we will do, we are writing Q1 as this one, since one identity we have learned that epsilon dot r equals to r, so Q1 equals to 0 star. Similar for Q2, if you apply Arden's theorem, will come up with this, so the regular expression will be like this. Please try it out of your own step by step, following step by step procedure. So this is the end of today's lecture. Next we will learn more examples. The finite automata will be given, and we have to find out the corresponding regular expression. Thank you.